Hello, so this is a revision video for IB Chemistry S1.3.2 for hydrogen emission spectrum and energy levels. This is a revision video, so only the essential information is covered. For more detailed explanations and for full video lessons, please check the links in the description below and visit chemistrystudent.com. A hydrogen atom contains only one electron. This electron can absorb energy and become excited to a higher energy level. When the electron falls back down to a lower energy level, however, it emits a photon of light of a particular wavelength. The energy of this photon corresponds exactly to the difference in energy between the higher, excited energy level and lower energy level. Because electrons in atoms can only exist at specific quantized energy levels, only certain transitions are possible. This means only specific amounts of energy, or wavelengths of light, can be emitted as the electron falls back down to lower energy levels. As a result, hydrogen produces a line spectrum, not a continuous spectrum. If you're at all unsure about that, please check the revision video on S1.3.2 Emission Spectra. It covers this in a lot more detail. Each line in the hydrogen emission spectrum corresponds to an electron falling from a higher energy level to a lower one. The lines aren't evenly spaced. The spacing gets smaller at higher energies because the energy levels converge, get closer together, as you move further from the nucleus. The bigger the energy gap for a transition, the higher the energy of the emitted photon. The smaller the gap, the lower the photon's energy. You need to understand how different transitions in hydrogen correspond to different regions of the electromagnetic spectrum. Transitions to n equals 1 involve very large energy changes, and emitted light falls in the ultraviolet UV part of the spectrum. Transitions to n equals 2 have slightly smaller energy changes, and the emitted light is in the visible region of the electromagnetic spectrum. These are the coloured spectral lines we see in the hydrogen emission spectrum. Transitions to n equals 3 cause much smaller energy changes, and the emitted light is in the infrared region of the electromagnetic spectrum. Because the hydrogen spectrum shows only specific lines and it doesn't show a full rainbow or continuous spectrum, this provides evidence that the electron in a hydrogen atom can only occupy specific energy levels. It can't be at any distance from the nucleus. The converging pattern at higher energies also shows that the energy levels get closer together as you move further away from the nucleus. This strongly supports the model of the atom having discrete, quantized energy levels rather than a continuous range of energies.